right, so for continuity, we have a function f is continuous at a point x equals c, provided that f of c exists, the limit as x approaches c of f of x exists, and the limit as x approaches c of f of x equals f of c. Okay, so let me kind of draw a picture and go through. Whenever you prove that a function is continuous at a point, there are three things that you have to show. Okay, I'm going to kind of draw a picture as I go. So if we have a graph here, okay, the three things that you must show, number 1 and 2 can be done in any order. I'm going to put the first one as the limit as x approaches c of f of x has to exist. So, for a limit to exist, let's say c is right here, and this is our function. I could have this, right? I could have a hole in the graph right there. My limit exists. Is that function continuous if I have that? It would not be considered continuous. A hole in the graph is a discontinuity. So, like if you think about tracing the graph, if you have to pick up your pencil to trace it, even if it's for a teeny tiny hole, then it would not be continuous. So, the limit existing alone does not guarantee that your function is continuous. Okay? You must also prove that f of c exists. Now, it can be true, I'm going to do this in red, it could be true. So if I do this, 1 and 2 are both true, right? The limit at c exists, f of c also exists if I have a closed dot. Is this continuous? It is not, because if I trace it, I would have to trace along here. I'd have to pick up my pencil, hit that dot right there, and then pick my pencil back up to continue tracing, right? So this would not be continuous. So 1 and 2 must be true, but alone they are not enough to prove that a function is continuous. In order to, so 1 and 2 you can do in either order, doesn't matter which one comes first, but 3 has to be last. You must also show that the limit as x approaches c of f of x equals f of c. And so if that is true, then that means our dot can't be up here. Our dot would have to fill in that hole right there. And that would be continuous because you don't have a hole in the graph anymore. You can trace it and you will not have to pick up your pencil. So, if you are asked to show that something is continuous, you must do all three of these things. A lot of times students just find the limit and think that that is good enough. That is only a piece because a limit does not guarantee that it's continuous. You could have an open circle there. Okay, so let's look at what types of problems we're going to see. Now, one-sided limits. Let's talk about those a little bit. I gave you one from, I gave you a one-sided limit for the warm-up. You guys did pretty well on that, so we should be able to fly through this. If you have a limit as x approaches c of f of x, if it equals capital L, then your limit from both sides is also going to equal that value. We did this sort of the other way around, where when we were looking at graphs, we'd find the limit from the left and the limit from the right, and if they matched, then the limit from both sides was the same. Well, it's true if you already know the limit from both sides equals a value, then the limit from the left and the limit from the right are going to be the same. So you might be given a problem like example 1, where they ask you to find the limit as x approaches -3 from the right. But we don't really know any special ways to find that limit. So what you're going to do is you're going to do the problem like it is just a regular old limit problem. And in this particular one, what strategy do you think we should use? We should check direct substitution. If I do direct substitution, I know in the bottom I'm going to get 0. Yeah. And I'm pretty sure the top's going to give me 0 as well, so I'll have 0 over 0 for this. So we should definitely check that. It does not, we get 0 over 0 though. So then, what should I try? Let's factor. So, Troy, how does that top part factor? X plus 3, X plus 2. We got that X plus 3 on the bottom. That is going to cancel. So now we can just plug in. We have negative 3 plus 2, and that gives us negative 1. Now, that would be the limit from both sides. But if the limit from both sides is negative 1, the limit from the right is also negative 1. Okay, so now, if it ended up being a does not exist or something, we'd have to do something else. They'd have to give us a calculator to look at the graph, or they'd have to give us, we'd maybe have to make a table. We'd have to do something else. But if you can just find the limit like we've been doing algebraically, that limit is from both sides, so you can kind of just ignore the plus. Just you want to keep writing it down, but it doesn't change how you do the problem. The ones you most often see left and right for are the piecewise functions. So if we look at this, the limit where x approaches negative 2 from the right of f of x, I've got this piecewise graph or equation right here, and I need to use the correct notation. I like to just do this, limit as x approaches negative 2 from the right of f of x. I don't copy that problem down because it's piecewise and it's huge. I just call it f of x. They've already labeled it f of x, so I can call it f of x and not have to write it again here. And if I'm going to do f of x from the right, which equation should I use? The top equation or the bottom? The bottom. What? I don't have it or equal to. Does that matter? Does it matter for limits?
Every single value up until that.
At limits, are we getting to that number? At limits, we're just approaching. Now, if they asked me to find f of negative 2, it would matter. Okay? If I found f of negative 2, then I would be plugging into that top. I do negative 2 squared plus 2, because that's where my or equal to sign is at, and I would end up with the square root of 6 for that. But this is a limit, so it does not matter which one's the or equal to, because we're not talking about at negative 2. We're talking about approaching negative 2. And that's going to happen from this bottom side. So we'll have 3 over negative 2 plus 1, which will give us 3 over negative 1, which is negative 3. Okay, questions there? All right, now if we have to do number 3, we're doing the limit as x approaches 3 of f of x from which side? Both. So, if it's a free response question, you can get by with shortcutting this. But, I'm sorry, if it's multiple choice, you can get by with shortcutting this. If this is free response, you must use limit notation. On that first test that you guys will have, I try to put notes use limit notation here, because you're not used to being graded on things being precise. A lot of times I don't grade really closely on your work, but it will happen on this. So if the limit as x approaches 3 of f of x exists, the limit from the left and the limit from the right have to be the same. So what we're going to do is we will do the limit as x approaches 3 from the left of f of x. And from the left, I should use that top function. So I would have 2 times 3 plus 5, which would give me 6 plus 5. So I would get 11. I would also need to check the limit as x approaches 3 from the right of f of x. Make sure when you do this that you are writing that f of x right there. You got to have the limit of something. Don't leave that blank. And then we would have 14 minus 3, and that would also give me 11. Okay? So, since the limit as x approaches 3 from the right of f of x equals the limit as x approaches 3 from the left of f of x, the limit as x approaches 3 from both sides of f of x would equal 11. Now, I've not proved continuity there. I've not proved it's continuous. I've just proved the limit exists. I would have to go further to prove continuity, which we'll see in some of the next problems. This is just showing the limit exists. Okay, questions there? All right, so let's look at, this is the full-blown prove that something is continuous. You're going to mostly see these with piecewise functions. Mostly. Sometimes maybe with a graph or something, even though I don't know if I put those on here. But mostly with piecewise functions is where you're going to see this. So, we're going to prove that the following function is continuous at x equals 2. So, I have to prove 3 things. I'm gonna jot them down up here just to remind myself of what I got to prove. I got to prove that limit as x approaches 2 of f of x exists. I've got to prove that f of 2 exists. And I've got to prove that limit as x approaches 2 of f of x equals f of 2. All right, and I've got to state all of those things. Okay, if you do go to college and major in math, a lot of the classes that you have will have you proving things that I mean, yes, right answers are important, but explicitly stating them. Like if you look back at mathematicians over time, they didn't just like come up with a good idea and were like, you know what? I think that pi is this, right? They had to prove that pi was this value, and this is how you would do it. So they have to think through it logically and write that out so that other mathematicians can say, oh, that does have to be true. Because there have been some things that, and I need a good example as I talk about this, but there have been some things that seemed to be true, but turned out not to be always true. They were just true in a lot of cases. So you got to prove that this is the case. And to prove that this is continuous, we have to do these 3 things. So I sometimes actually start with that middle one just because it's easier a lot of times. If I want to find f of 2, I would just see wherever my or equal to sign is, and I would plug in. So I'd get 3 times 2 minus 4, which is going to be 6 minus 4, which will give me 2. All right, so that shows that f of 2 exists. I've done that. Now I need to show that the limit as x approaches 2 of f of x exists. But to do that for a piecewise function, I have to show that the limit from the left and the limit from the right are equal to each other. That shows that the limit exists. So I would need to first do the limit as x approaches 2 from the left of f of x, which would be the top function, 3 times 2 minus 4, which is going to give us 2, just like we got for f of 2. I would need to say that the limit as x approaches 2 from the right of f of x would be 2 times 2 squared minus 6, which is going to be 2 times 4 minus 6, which is 8 minus 6, which also equals 2. And so I have shown limit from the left is 2, limit from the right is 2, and then I don't know that I've used this for you guys ever. These 3 dots right here, they are a fancy symbol. Mathematicians like to use as few words as possible, so they just make up symbols for words so they don't have to write them out. This symbol right here is an accepted mathematical symbol that means therefore. If you want, you can write the word therefore out, but why when you could just put those 3 little dots, and then then you don't have to worry about all those letters and things. So therefore, we would say that the limit as x approaches 2 of f of x equals 2. So you need to make that conclusion. You want to do the limit from the left, limit from the right, and then make the conclusion that since they're the same, that limit exists at 2. All right, so we've done this first thing, f of 2. We've done the second thing where we've shown that the limit exists, so that is good. And they are equal to each other, so we can make our final conclusion. We can say since limit as x approaches 2 of f of x equals f of 2, f of x is continuous at x equals 2. So that is our third thing. We're making our final conclusion, and we have proven that this is continuous. Let me see if I have an example on that. But if it fails, so like as soon as one of these fail, so if your limit does not exist, you would, maybe we get a 2 here and an 8 here. We would say, therefore, the limit as x approaches 2 of f of x does not exist, and therefore f is not continuous. So as soon as one of these fails, you can say that it's not continuous. So if the limit does not exist, go ahead and say it's not continuous. You don't have to check anything else. If f of 2 does not exist, that's one reason I kind of do it first, because if f of 2 doesn't exist, it's like the quickest and easiest one to do. If it does not exist, you don't even have to check the limit. You say f of 2 does not exist, therefore f is not continuous at 2. So if any of this fails, then you would say it's not continuous. The longest way it may not be continuous is maybe f of 2 does exist, the limit exists, but they don't match each other. So like if this was 4 and this was 2, we'd say since limit as x approaches 2 of f of x does not equal f of 2, f is not continuous at x equals 2. So all 3 of these must be true in order for it to be continuous. If it's not, you'd make the conclusion that it is not continuous at that point. I might have an example of that, but I can't remember. Okay, questions? Okay. All right, I don't have a lot of room right here. I want you guys to do this one, and I want you to write it it's asking for 2 different places. It's asking for 2 different places because you've got 3 pieces to this piecewise function. Borrow that right there because I think that is helpful to see. All right. Has somebody finished the second part for the -5 that's willing to be picked on? Let's see what, I'm going to borrow what you have here. Okay? Let's see. I wouldn't have to zoom in though. All right. So, Joshua says, and he showed work up here for finding the limit as x approaches -5 of f of x, and the limit as x approaches 5 from the right of f of x, and he got 14 for both of those. So, if I realize I don't have a lot of room on this paper, you'd put it all together, but you would also have plenty of room to do that on a real assignment. And then he says that the limit as x approaches 5 of f of x equals 14, I would not write out limit right there because that would not be like standard math notation there, but it's not a big deal. Since the limit as x approaches 5 of f of x equals f of 5, f of x is continuous at x equals 5. And I think that looks good. Did you find f of 5 somewhere, though? Yes, you did. Up here, you found f of 5. So you want to have that stated, like where you found each one. Obviously, on a real test, we would have all that together and not kind of scattered, but I didn't give you much room on this paper. All right, so he has listed everything there. Okay, questions? As far as like writing it out, like at the first part, no. But all 3 of those must be addressed if it is continuous. So, like Joshua did that because he found f of 5 and it equals 14. So, if you show that it equals a number, that shows that it exists. You don't have to say it exists. He found limits from both sides and also made the conclusion that the limit exists, or it equals 14 since they equal, actually he did, he probably should have like these 2 together and therefore say the limit, like say, put those in a line there, like you would do limit as x approaches negative 5 is 14, limit as x approaches 5 from the right is 14, and then say, therefore, the limit as x approaches 5 of f of x equals 14. If it were all in one spot, though, I think I'd read that all together for that. So you have to show f of 5, you have to do limit as x approaches 5, and then show that those 2 are equal to each other to make the conclusion. There. Okay, questions? Okay. I think I told most people that I saw this on to fix it, but I was seeing some naked limits. Let me show you what one looks like. I hate to even write something so vulgar on the screen, but limit as x approaches 5 from the left equals, and then doing 2 times 5 plus 4. Okay, that is a naked limit. Because you just have the limit as x approaches 5 from the left. I know that you're assuming I know that's f of x, but you have to write it. Because this is not, you can't have a limit of nothing. So right here, you've got to put f of x right there. So make sure when you have a limit that there is something behind it. It could either be an equation or it could be just the f of x, which is what I usually write because it's quicker and easier to write. But it has to be there because without it, that's a naked limit. Naked limit is my term. That's not an official mathematical term. So when you get to college and your PhD professor is teaching you, maybe we don't use that term, but or at least don't say as high as said it. But just watch out for that. Okay, everybody good there? Okay, here is another fun kind of problem. I like these. All right, we need to know what value of b will make f of x continuous at x equals 3. So, I can see up here I've got a piecewise, but this is a different type of piecewise than we've seen on a lot of the others. X cannot equal 3. What numbers does that include? Everything but 3. So that means we're using this equation for everything except for 3. And then at 3, we've got some value b right here. So notice if I plug in 3 into this, if I plug in 3 in the top, I get 0. If I plug 3 into the bottom, I get 9 minus 6 minus 3, which is also 0. The reason we cannot use 3 is because this is going to be an indeterminate form if we do that. All right. So that's normally going to be the case with this. So what happens is probably in these cases, this function has a hole. And what we're wanting to know is what value should we put here to fill in that hole. So the way that we would do that is we would do the limit as x approaches 3. It's going to be from both sides because this is defined everywhere except for -3. So it's going to approach 3 from both sides, right? Because it's just one little dot where it's not defined there. So that would be, I'm going to still use limit notation because I still have x's. I'm going to have x minus 3 on the top. I'm going to factor that denominator. Jeremy, how's that factor for me? We got to multiply to get -3, add or subtract to get -2, plus 1 minus 3 there. And so these would cancel. I could plug in my 3. Remember, you'll have like a placeholder 1 in the top since everything canceled out there. I'll get 3 plus 1, which will be 1/4. So remember, whenever you're doing a limit, this is your y value that you're getting out. So you have a whole at 1/4, right? Because that is the place where you have, you have a whole at 3. 1/4 is the y value that you would get. So what we need to do is say that b should equal 1/4. Now, this did not ask you to prove that it's continuous, right? So you don't have to go through all the steps of limit from the left, limit from the right, f of whatever. It's just asking you to find the value that would make it continuous. If it said something like prove or justify your answer, you might need to go through those other steps. But a lot of times these show up on multiple choice. Here. All right, let's try another one. We got f of x equals 8 over x plus b for x is less than or equal to 2, and 2x minus b is for x is greater than 2. So we want to find the values of b, value or values, there could be more than one, that will make f of x continuous at 2. So this time I do have like a limit from the left, limit from the right sort of situation, right? So what I'm going to do is I need to do the limit as x approaches 2 from the left of f of x. Which I'm going to write this out. From the left, that would be the limit as x approaches 2 from the left of 8 over x plus b. Now, I need to plug in my 2. What am I plugging my 2 in for? I'm plugging in for x. So that would give me 8 over 2 plus b. The b is still in my answer here. Yeah, it is b, sorry. I should go back and type these better, but there's no time for that. So I got something, but still got a b. All right, so let's move on to the right side. I've got limit as x approaches 2 from the right of f of x. Okay, that would be the bottom equation. So that'd be 2x plus b. And if I plug in 2 for my x, I would have 2 times 2. Oh, it is a minus, thank you. Minus b, 2 times 2 minus b, which would give me 4 minus b. Now, that does not give me an answer. I got b's in both of the things that I got, right? But what has to be true in order for f of x to be continuous at 2? They have to equal each other, right? So we can take our answer from our limit from the left and our answer from the limit of from the right, and we can set them equal to each other. So we got 8 over 2 plus b equals 4 minus b. Now, this is going to test some algebra skills out here. How do I solve that for b? We can't solve when we got something in the denominator, so we'd multiply by 2 plus b here, which would just cancel out. And then make sure you put me some parentheses around that 4 minus b, and you're multiplying by 2 plus b over here. So I got 8 equals, how do I multiply those together? We got to FOIL, we got to distribute, we'll get 8 plus 4b minus 2b minus b squared. So 8 will equal 8 plus 2b minus b squared. Alright. How do I solve that? So, well, it really doesn't matter which way I think about it, left or right. I'm going to subtract that 8. Now I got 0 equals 2b minus b squared.
Like some Shakespeare stuff.
Yeah. So, how to solve that? What?
B squared is just 2b. Times 2b minus 2b, which is 0.
0 is going to be a correct answer, but your logic is not going to work.
What do you divide by 2?
You could, but it's going. If you divide by 2, it's going to give you a 1/2 right there with the b, because you'd have to divide this and this. Exactly. Okay, so this is a quadratic. Quadratics, you want to move everything to one side, and you want to factor if possible. If you can't factor, you want to use quadratic formula. This one will factor. It's just the greatest common factor. So we pull the b out, and we get 2 minus b. All right? And so then what do I do once I factor it? I don't think so.
Divide the b.
If you divide the b, you'll lose the answer. You'll get one of the answers right, but you'll lose an answer. If anything multiplied by 0 equals 0, right? So if this equals 0, the whole thing's going to be 0. If this equals 0, the whole thing is going to be 0, right? So it's the zero product property. It's what we did when we were solving quadratics. You set each one equal to 0. It only works if it's equal to 0. If it's equals to 2, you can't do that. You need to go back and do something different. So then if I just add my b right here, 2 would equal 0. I'm sorry, 2 would equal b. 2 does not equal 0. It equals both in this case. So there are 2 values of b that would make this true. Well, that dug deep for back to some algebra skills, didn't it? Got a little bit of rational equations, had quadratic, had the factor. So you will sometimes see these things. All right. Okay. Let's practice what would be like a free response question that you would see. And you're going to have one of these on your homework. For this, we will, okay. All right, so let's start with this. For what value of k, if any, is f continuous at x equals -3? All right, so if we're only looking at x equals -3, I don't have to look at all of the equations here. I just need to look at a couple of them. Which 2 do I need to look at? Top and middle, because I've got x is less than -3 here and the -3 here also. So for continuity, I'm looking at the top and the middle. So if I look at the top one, limit as x approaches 3 from the left of f of x. I'm sorry, that should be a -3 from the left. I would just be plugging into that top equation. Is it going to give me 0 over 0? Let's see. I think so. Let's go ahead and factor that. So if I factor the top, I got a 2x and an x. The bottom, let's see, I've got I'd have a plus 3 here and a minus 1. Does that work? Positive, yeah, that'll work. And then the bottom, if I factor, I'll get x plus 3, x plus 1. And so I could cancel out my x plus 3's, and I could plug in my negative 3. So 2 times negative 3 minus 1 over negative 3 plus 1. So that is going to be negative 7 over negative 2, so 7 halves. Yes. Yeah. This would be like a free response question on the test, so you would, yeah. And then from the right, our limit as x approaches negative 3 from the right of f of x is going to be k. Let's see. I guess I could go ahead and plug in. I'm plugging in negative 3 for my x, so it's k times negative 3 plus 1/2, which I could write as negative 3k plus 1/2. So right here is my limit from the right here is my limit from the left. For f to be continuous at negative 3, what has to be true? Those two must be equal to each other. So at this point, I can do negative 3k plus 1/2 equals 7 halves. This is just a two-step equation. Here it does have some fractions, but they're not too bad. I would subtract 1/2 from both sides. Negative 3k. That'll give you 6 halves, which is just 3. And I'll divide by that negative 3. So k would equal negative 1. It says justify your answer, but your work using that limit notation is justifying your answer. Showing your work there justifies why that is the case. Okay. For B, it says, what type of discontinuity does f have at x equals 0? Give a reason for your answer. So, in this case, I would have the limit as x approaches 0 from the left of f of x. That would be, now, it doesn't tell you to use the negative 1 that you found in the last part. So we still got to use a k. We got k times 0 plus 1/2. So we got k plus 1/2. So from the left, I'm going to get k plus 1/2. From the right, limit as x approaches 0 from the right of f of x is going to be 2 to the 0 over 3 to the 0 minus 1, which is going to give us 1 over 1 minus 1, which is 1 over 0, which tells us right here the limit does not exist. And that is x approaches 0 from the right of f of x. Does not exist. When you get that does not exist from the equation, when you're getting that 1 over 0, you're looking at a vertical asymptote there. If you plug in 0, it's giving you a 0 in the denominator, which shows that it doesn't cancel out with the top. So while the limit from the left might actually exist, we would say that f of x has a vertical asymptote at x equals 0. So getting that 1 over 0 is telling you that, or it could be 7 over 0 or 100 over 0. Any number over 0 is telling you a vertical asymptote for that. It doesn't really matter what the left is in this case, because if you have a vertical asymptote on either side, you know it's going to be discontinuous. All right, we don't know how to find horizontal asymptotes, so we're going to learn that, but we don't know it yet. Your assignment tonight is on AP Classroom, and on AP Classroom, it is going to be, I think, 6 more. I don't have time to sign in and show you. I think it's going to be 6 multiple choice problems, and then there is a free response problem that's kind of similar to this. If it asks you for a horizontal asymptote, do not do that. I think it does. Don't do that part because we can't do that yet. The multiple choice, just do those on AP Classroom and submit them. The free response, it will allow you to upload pictures of your work, but I have found it's kind of a pain. Like, you got to upload a picture for each section. So instead, just write it on paper and I'll check it in class tomorrow. Okay? Go ahead and submit that last question blank, because that you have to submit it for me to be able to like release your grades so that you can see them. But just write it on paper and I'll just check it in class on paper, because it's just annoying. Valeria has a good question there. Why would k times 0 be k? It would not. What would it be? It would be 0, so I should have just got a 1/2 there. You're right. Thank you for catching that.